So I hope everybody hears me. Yeah. So first of all, I would like to thank to everybody for coming to this intellectual and science conference, and organized by Azerbaijan Student Network, named as Aserbaidschan-Forschung in Deutschland. And I warmly welcome all of you to this to the third panel, Science and Technology. So as we know, science and technology is a very important part of the innovation and new development. So I would like you to take attention to this panel and feel free to ask any questions you like. So as we know, nowadays the technology in Azerbaijan has increased a lot, and there is a lot of innovation in the projects. So we will speak some parts of these innovations, and mainly the parts of the geology will be discussed in this section. So some of the organization stuff and the timing of the schedule, the timing of the presentation. So there will be 4 participants, and each of them will be presenting their results, their research, or whatever they want to present. And to begin with, I would like to introduce also myself. I forgot this, sorry. I and my colleague Azat Heydarov will be moderating this panel. So my name is Emil Saibov. I am a PhD student at Deutsches Zentrum für Luft- und Raumfahrt an der Universität Stuttgart. My research project is a numerical calculation of thermochemical and thermophysical properties of gas to liquid kerosene from biomass. So as it's really some kind of engineering, maybe there is a lot of economics and politics here. Maybe it's far away from their specialty. And so I would like to give the first possibility for the presenter. He is Rasim Jannataliev. He did his bachelor and master degree in Technical University of Azerbaijan, and he is now working in Hochschule für Technik in Stuttgart, Germany, as a guest scientist, and he will be giving an introduction of reduction of primary energy reversible heat pumps through the optimization of heat sources and sinks. So I would like to take attention to his presentation, and if you have any questions at the end of the presentation, you can ask, and feel free to ask any questions you like. So.
Hallo, sehr geehrte Damen und Herren. Leider ich könnte nicht schnell Präsentation vorbereiten. Ich hatte viele Reports geschickt und so. Ich habe alles in Word geschrieben, aber ich alle erzähle und Sie können auch später die Frage anstellen. Ich bin Gastwissenschaftler an der Hochschule für Technik Stuttgart. Ich mache da meine Promotion. Meine Promotion im Bereich das Thema heißt primäre Energiereduzierung von der reversible Wärmepumpe durch.
Das funktioniert nicht nur für PowerPoint, wir müssen mit den Reihen arbeiten.
Okay. Primäre Energiereduzierung von reversible Wärmepumpe durch Optimierung von Wärmequellen und Senken. In Okay. Im 21. Jahrhundert der Welt hat mit ökologischen Problemen zusammengestoßen, und um diese Probleme zu verringern, die führenden Länder des Welts in ökologische reine Kraftstoffart überzugehen. Zum erneuerbaren Energiequellen können Sie wir zum Beispiel Solarenergie, Windenergie und auch Geothermie überbringen. In meiner Arbeit, ich habe nur Solarenergie und Geothermie benutzt und ich möchte Ihnen Aufmerksamkeit nur um diese Energieformen zu beachten. Aserbaidschan hat sehr großes Potenzial für Geothermie und Solaranlage, Solarenergie, auch für Windenergie. Zum Beispiel Sonnenscheindauer in Aserbaidschan, das ungefähr 1800 Kilowattstunde pro Quadratmeter. Das ist zweimal mehr zum Beispiel, als wenn wir vergleichen das mit britische Insel. In britische Insel, das ist ungefähr 1000 Kilowattstunde pro Quadratmeter. Das verteilende Sonnenstrahlen in Aserbaidschan, wir können sehen, dass in ganz Aserbaidschan, auch in Küstenstreifen der Kaspische Meer, auch besonders in Halbinsel in Abschirm, die Sonnendauerstand ist sehr gut und das ist, wir können da sehr gut die Hybridanlage zu nutzen. Die Solaranlage, die meistens können erzeugen Heizanwendung, für Kühlanwendung, auch für Stromanwendung. In meiner Arbeit, gibt es jetzt die neue Solaranlage, das heißt PVT. In der Vergangenheit war nur PV-Anlage und Solarkollektoren. PV-Anlage erzeugt nur Strom und Solarkollektoren, die Leute haben benutzt und bis jetzt nutzen, nur für Heizanwendung. In meiner Arbeit ich nutze das Hybridanlage. Sie können parallel Strom erzeugen und auch Heizung erzeugen. Aserbaidschan hat auch sehr großes Potenzial für Geothermie, bis jetzt das nicht genutzt. Zum Beispiel im Großkaukasusgebiet gibt es sehr großes Potenzial. Im Kleinkaukasusgebiet, in Nakhchivan, auch im Südaserbaidschan, wir haben sehr großes Potenzial für Geothermie. Zum Beispiel im Nordaserbaidschan gibt es ein Gebiet, heißt Hudat, gibt es da eine Quelle mit Temperatur 72 Grad. Und wir haben auch im Gebiet Gobustan Mudvulkanus, auch ein bisschen im Nordkaukasusgebiet. In diesem Gebiet Mudvulkanus, wir können auch ohne ökologische Störung Geothermieanlage zu nutzen. Geothermieanlage auch wie Solaranlage können für Heizanwendung, Kühlanwendung, auch für Stromanwendung nutzen. Die Experimentalanlage, die meistens Hauptkomponent das private Kollektoren und auch Geothermie-Erdwärmepumpe. Und wir können auch andere Teil, das Pufferspeicher, Umweltpumpe, Regelventile, Wärmetausch, Temperatur, Druck, das ist alles Komfortteil, das nicht kombiniert. Ich mache das weiter, weil ich bin ja nur ein Jahr, ich bin nur am Anfang meiner Arbeit. Meine Hybridanlage im Winterzeit können arbeiten zum Gebäude für Heizanwendung und auch für Warmwasservorbereitung. Im Winter, im Sommeranlage, die Temperatur im Erde, im Sol, das plus 7, plus 12 Grad Celsius. Das ist genug, das Gebäude gut kühlen und auch parallel von Solarkollektoren wie im Sommer, wir können auch Heizwasser bekommen. Das ist gut auch, und diese Anlage kann selber durch PV seinen Bedarf im Strom bedenken. Und was ist auch interessant mit meiner Anlage, diese Anlage kann unabhängig vom Stromnetz benutzen und auch parallel. Und zum Beispiel, wenn Sie in Sommerzeit gehen zum Urlaub oder so, Sie können gekriegten Strom im Stromnetz für die Regierung verkaufen. Und Sie bekommen für das Geld. Ich weiß, dass in Deutschland gibt es schon diese Regal, bei uns das noch nicht, nur klein, aber erwachsen in Zukunft, weil wir haben nicht so viel Anlage und nur in diesem Jahr Unternehmen für PV-Produktion das Gebot jetzt. Und am Ende dieses Jahr, diese Produktion geht weiter. Wir produzieren jetzt nur PV, das in Stadt Sumgayit, nicht so weit von der Hauptstadt Baku. Antwort, das Aktualität meiner Arbeit, dass wir können ein Energieeffizienzsystem bauen für Winter, Heizanwendung, Warmwasserverbreitung, für Sommer, Kühlanwendung und auch Warmwasserverbreitung, auch Strom. Das ist sehr gut. Und was ist Ziel für meine Arbeit? Die organischen Brennstoffe einzusparen und Ausfuhr CO2 in die Atmosphäre zu verringern. Das ist sehr wichtig, ich denke. Vielen Dank für eure Aufmerksamkeit.
Okay, thank you for your presentation. Now, if there is any questions, you can ask from him directly.
Ja, also ich fand das sehr interessant, aber ich habe so ein bisschen das Gefühl, also es gibt viele Ähnlichkeiten mit Deutschland. Also ich habe das so verstanden, du möchtest halt, wie du sagtest, zum Schluss von diesen ganzen Ressourcen weg, auch so, also diese zentrale Stromversorgung willst du ein bisschen weghaben und dafür so diese dezentrale mit verschiedenen kleinen Kraftwerken und Sonnenrädern. Aber dafür muss das Stromnetz ja komplett neu gemacht werden. Wir sollen das alles bezahlen. Wir in Deutschland können es auch heute noch überhaupt nicht leisten. Das ist ja richtig, richtig viel Geld, dieses ganze Stromnetz so dezentralisiert, auch in Aserbaidschan. Was denkst du, wie viel das kostet und wie lange das dauert?
Das ist schwierig gefragt, das ist ein Schwerpunkt. Das kostet natürlich in der Zeit zu viel, was du kannst kriegen zurück vielleicht nach 10 oder 15 Jahren. Aber für Ökologie, ich habe gehört, dass in Deutschland jetzt Atomkraftwerke werden geschlossen, ich weiß nicht wann. Und die Kilowatt pro Stunde für Strom wird 70 Cent. Und wenn die Leute denken, was ist günstiger, sie werden zum Beispiel in diese Technologie gehen.
Und wie lange soll das gebaut werden alles, das ganze Stromnetz? Was glaubst du?
So, das ist, du kannst sehen, was möchtest du beim Groß- oder Kleinunternehmen oder Fabrik oder Haus, ich weiß nicht. Du musst entscheiden zuerst, was willst du bauen, dann willst du, wie geht das?
Ich glaube, Verständnisfrage dazu, man kann ja auch off-grid machen, also muss ja nicht ans Netz angebunden sein. Also ich glaube, ich habe das so verstanden, dass seine...
Ich habe gesagt, das ist nicht zentral.
Das ist nur privat. Also soll das ein Dorf dann sozusagen, das ein Dorf von einem kleinen Biokraftwerk sich speist oder soll das an alle, an ganz Aserbaidschan?
Ich mache jetzt, das ist nur für die Gebäude, was in Belgien ohne Stromnetz oder im Stromnetz. Okay. Ja, das ist günstig für diese Menschen, was kaufen und machen. Nicht für die, der in die Stadt wohnen.
I have also, you want to ask? Okay, there is a question.
Bist du irgendwie Techniker oder was ist dein Background? Hast du die Anlagen selbst entworfen oder mitgestaltet oder möchtest du die vermarkten? Was ist deine Rolle dabei?
Ich bin einfach Forscher.
Ja.
Und zuerst ich mache Simulation in verschiedenen Software. Und wenn ich kriege ähnliche Datei, ich habe gesagt, ich bin nur erste Jahr hier arbeite, ich bin am Anfang. Ich mache verschiedene Forschung und wenn ich die Datei kriege, dann entscheide, was ist besser und kann ich das einbauen und einfach dieses Gebäude einbauen und machen, wie arbeitet das. Zuerst ich soll technische Datei bekommen.
Also diese Anlage, diese PVT-Anlage existiert existiert schon? Also
Schon jetzt gibt es, ja. Gibt es, wenn du siehst im Internet, gibt es Maximum 400 Artikel in diesem Bereich. Mit Kombination so wenig, weil das ist so ein frisches Thema. Aber PHP gibt es schon.
I want also to ask a question from you. For example, you say the solar energy. The energy production of the solar energy, when you compare with the thermal waste treatment plants or power plants, is contradictory and it's very less. And what's your approach for this kind of energy production that can obtain from solar energy, as well as the costs, as we talked about right now, and it's cost really a lot. But when you, for example, there's such project and a French company, Technik, now constructs the thermal waste treatment plants in Azerbaijan, and by this there is also environmental free and environmental reduction of air pollution as well as the wastewater pollution. And by that the pollution of the Baku country will be reduced to 10 volume. And what's the and if you say solar energy and this kind of power, this kind of plants, they will be costly, and what's the efficiency of this kind of processing?
Okay, ich antworte zuerst auf Effizienz. Die PHP-Anlage, die normal Solarkollektoren nutzen nur die 30% von ganzen Sonnenstrahlung auf die PHP-Kollektoren. Aber PHP-Kollektoren nutzen ganze 100%, weil wenn die Kollektoren erzeugen Strom, die Temperatur im PV geht hoch als in den normalen PV-Kollektoren. Und wenn diese Kaltmittel durchläuft, sie bringt mehr Energie als im normalen PV-Kollektor. Und das schon gibt es Mehrheitsgeld, und viele Forscher haben das geschrieben, dass 100% günstiger. Die normalen PV-Kollektoren nutzen nur 30% von ganzer Energie, aber PV nutzen 100%, und das ist sehr, sehr effizient. Und über die Politik jetzt, Ilham Aliyev hat ein Dokument geschrieben in 2004, und Aserbaidschan Regierung unterstützt alle Promotion, Forschung, alles, was ist im Bereich erneuerbare Energie mit Solar, Windanlage, alles. Und ich habe auch ein Projekt von meiner Stipendienvergabe mit Aserbaidschan Energieministerium. Sie haben mir gesagt, wenn ich mache ein Projekt, sie geben einfach für mich Geld, das ist einfach bauen in Aserbaidschan. Das ist kein Problem.
Eine organisatorische Frage. Kannst du dein Mikrofon etwas weiter vom Mund weghalten, weil sonst versteht dich nicht.
So?
Ja, ein Stück so ungefähr so auf der Höhe. So dafür ist es eigentlich gemacht.
Okay.
So. Ja, danke.
Yeah. Any other questions, please? So the information that Mr. Janatiev gave us was very interesting, since the solar energy is a new kind of the technology that gives energy production, especially in Azerbaijan. This will be a new kind of technology that will be constructed. So I would like to continue with the second presentation. So just
Which one? Elizabeth State Oil Academy? No?
so
Yes, this one. Okay. Yeah. Okay, and
so I would like to give information about the next presenter. He's Javad Ustamov. He's an undergraduate student, Bachelor of Science at Azerbaijan State Oil Academy, and now he's doing a semester in University of Nuremberg. He has a good work experience. For example, he was a president for Azerbaijan Society of Petroleum for Geologists in Azerbaijan State Oil Academy, and he has trainings as a research and interpretation of sedimentation process in British Petroleum Baku, Azerbaijan. And he has also another activities such as projects in exploration of geology, field analysis, the Horizon 5-6 of Galafi, and so on. Now you can start with your presentation. And
everybody hear me? Okay, first of all I would like to thank the organizers and the sponsors for arranging this conference, that letting me the chance to see Berlin and to attempt this one. So I would like to speak about the mechanisms of the South Caspian megabasin formation and its potential of oil and gas generation. First, it should be said that most of the researchers believe that the South Caspian megabasin or megadepression was the relic of the Tethys Ocean. As it goes from the paleoreconstructions compiled on Gomkrulidze seams, the Iranian and Afghan microplate and Anatolian was detached from the African continent and moved in the submeridional direction, closing Paleotethys on the north with the simultaneously opening of Mesotethys in its rear part. In the late Jurassic, you can see that the Iranian Afghan microplate faces the Eurasia continent, and that's how the process of subduction process began, the Kopit-Dak subduction process. From the late Mesozoic till the late Miocene, Oligocene, sorry, the South Caspian megabasin and the Black Sea was the deep water hollows of the ocean Tethys. However, in the Miocene, sorry, I forgot to say that the narrow part of Iran and Afghan microplate didn't have such an opportunity to participate in the subduction zone. That's why it wasn't banded, let's say like that. So, according to Sonnenschein, that's actually the modern plan of South Caspian depression and the plan around it. The Arabian microplate moved to the northeastern part, pushing the Anatolian plate to the west-northern part, and the Indian, yes, that's how it was going, and the Indian plate was moving in the north. So the Iran and Afghan microplate was moving like that, bending the narrow part of bending of narrow part, where the Elbrus collision began. So the South Caspian, it should be said that the South Caspian megabasin had its overland extension that is shown in the Low Kura Basin. This is the Low Kura Basin, which eastern part is the western part of South Caspian megabasin. So yes, there are different indicators showing that there were compressing stresses in the South Caspian megabasin. For example, the intense mud volcano that took place in both Baku archipelago and in the Baku archipelago and Low Kura Basin show that the compressive stresses took place also here. Also, the Elbrus collision that was shown here, the bending of this collision also showed the compressing stresses. Then the thickness expansion or near the Baku archipelago shows the compressing expansion because due to the compressing expansion the middle and upper Miocene deposits were lifted. So okay, from the foregoing it's clear that the formation of sedimentary cover of the South Caspian megabasin occurred under the favorable paleotectonic, paleogeographic and paleodynamical processes. And due to the paleogeographic conditions of the sedimentation in the low facies complexes accumulated the organic material in an amount of its Clark value. For those who don't know, the amount of Clark value, the normal amount of Clark value is 0.4 to 0.5. The process of South Caspian megabasins sedimentary cover formation is divided into 4 parts. The first one is the Mesozoic part. As you can see, there is no sufficient difference in the sedimentation rate here, because in this period the South Caspian was a marginal sea and it had the regime of the ocean regime. But after the late Oligocene, it turned into the intercontinental sea, where and due to that lots changed, because the intense of mud volcanoes and the compressing stresses brought the sudden raising in the sedimentation rate and in double raise of the compressing stresses. So in the microbe, as you can see, there is no sufficient difference as well, but here was the sedimentation rate was 135 meters million years, with the capacity of 270. So from that you can make a calculations and count that the percentage of organic material here is more than 2%. After that, in the late Mesozoic and lower Miocene zone, you can see the sudden raising of the sedimentation rate. It goes due to the regime of total compression and also the intense lifting and the convergence of the Lesser and Greater Caucasus. All these indicators made the sedimentation rate raise, and here you can see that the sedimentation rate here goes 420 meters million years, with a capacity of the 4,300 meters. This process was taking place for 6 million years, and the consistency of this during this period was mainly clay deposits. After that, in the Neogen zone, you can see that there was the broad development of the compressing stresses. Here, in the capacity of 8,900 meters, the sedimentation rate is approximately 1,450 from 1,450 to 1,600 meters million years. Here you can see that the percentage of organic material is much more bigger than 2%. For your information, it should be said also that due to the mud volcanoes that played a role of the raise of sedimentation, the amount of Azerbaijan takes the first place in an amount of mud volcanoes. Then, according, as it was mentioned before, the sedimentary layer or the of Azerbaijan is the approximately 24 kilometers. So here you can see different here was different lithofacies complexes, such as Mesozoic or Pliocene, or Paleogene Eocene, or Oligocene, Lower Miocene, Middle and Upper Miocene, Lower Pliocene, and Upper Pliocene Phycozoic. So if we count that all these lithofacies complexes were formed in a good paleogeographic paleotectonic conditions, then we can make a conclusion that either all these lithofacies complexes are the source sections, or in these lithofacies complexes we have the layers of source sections. From that we can make a conclusion that in the South Caspian depression of the sedimentary filling, we have got the row of source sections in the different absolute levels. It's also known that the source section is a layer that contains the rock with organic material that is with a Clark value higher or with the same amount of 0.4, 0.6 0.6. As the mass transformation of the organic material into hydrocarbons goes in the special oil window or the main zone of oil generation that can be seen here in the temperature interval from 15 till 16 till 150 degrees. In this, based on the temperature data of the deep well, it was determined that the board isotherms in this picture, comparing to the lithophase complexes, we can make the conclusion that right now, nowadays, the main oil and gas bearing layer is the lower Pliocene lithophase complexes. But we can't testify that hydrocarbons deposits in its cutting are idiogenous, and because of the time that was spent on the heating of the organic material to transform it into hydrocarbons. That's why it's more possible to predict that the formation of oil and gas deposits, which are in the lower Pliocene and upper Miocene, sorry. Yeah, sorry. Being out of the main zone of oil generation, and they can be turned into the hydrocarbons in the first stage of main zone of gas generation. That means it can be transformed in temperature intervals from 150 to 250 degrees. It's well known that the source sections which go into the main zone of gas generation and began to produce hydrocarbons in a commercial importance are the petroleogenetic layers. The sedimentary filling of South Caspian Depression can produce hydrocarbons continuously because of the source section that are situated on different levels. So when one layer goes out of the main zone of oil generation, another one takes its place. So from all above mentioned goes that South Caspian Depression is polycentered and also it's different centered zone. Also, all the basins are open hydrodynamic systems, which means that the formated fluids are not fully caught by the natural traps, but also go on the surface of the level and can be distracted over there. According to the Dadashev, on the Asian surface in the region of Absheron Peninsula was taken billions of meter cubes of oil, of gas, and millions of tons of oil. If we count that the value of the natural leak in each year just 1 million ton, then during the 0.5 million years we lost approximately 5.10 in 11th grade meter cube of gas and 5.10 in 14th grade tons of oil. These amounts exceed in many times the whole geology deposits, not only in Absheron but also in the whole South Caspian Depression. So I would like to give you a little bit data of the quantity of deposits also in Azerbaijan. Sorry. It should be said that the ultimate potential resources in Azerbaijan generally can be divided into unique from 500 to 1,000 tons of oil equivalent to the largest from 100 to 500, the large from 10 to 50 billion tons, and middle from 1 to 10, and small less than 1 million. Azerbaijan, South Caspian Basin, due to the ultimate potential resources, refers to the largest largest oil fields. It has it was explored approximately 88 oil fields, in which 4 refers to the largest, such as ARiG, I will show you on the map. Yeah. So ARiG, Shah Deniz, and Götürtepe. Also Balakhanı, Sabunchi, Ramani. Oil fields such as Nevdaşları, Surakhane, Bibi-Ibad refers to the large oil fields with the original geology resources approximately 100 to 500 million tons of oil equivalent. Starting from talking about the ARiG oil field, starting from 80s on the west side of South Caspian, this oil field was explored, and at the end of 19th, the Shah Deniz one. The deep part of the ARiG oil field is on the prime stage of development, and was actually at the beginning of 2007. It was produced only 75 million tons of oil with an original geology resources, more than 2 billion tons. The biggest gas field, Shah Deniz, with a preliminary estimate of explored deposits more than 1 trillion meter cubes and 300 million tons of oil, was put in the production in 2007. So, thank you for your attention. If you have any questions, please give me I will try to answer them.
I have one question.
Yep.
I think everybody is very interesting about the oil and gas reserves, as well as oil and gas production. And it was very nice presentation from your side to give us short information, and they present your result about this research area. And I have 2 questions concerning to the oil and gas reserves. The first one is, you say that the main oil and gas generation happens mainly in lower Pliocene and upper Miocene.
Yeah.
And could you please give also explanation what's the capacity of this oil generation in this part? And the second question is that everybody is mostly in scientific community is focused on the part of the oil generation and oil reserves in the Azerbaijan. So in the past 10 years, there was such an announcement that oil reserves will be last for 40 years. And what's your approach? What's your information about these oil reserves that's in Azerbaijan, particularly in the in that regions that you have in your research?
Actually, right now, as far as I know, the Azerbaijan geophysicist is exploring the MICOP lithophase complexes, and we still have got a lot of others that lithophase complexes that was early formed. So I don't have actually this information, but I guess that this will be more than 40 years, because you know, more oil we produce, more oil we need, and we have got a big deposits right now, and I guess that there are a lot of other oil fields that were not explored till right now. So I think that we'll see what's going on in the future. And talking about the other question, can you repeat it?
I said
about the
that you say the main oil and gas generation is in the levels, in the layers of lower Pliocene and upper Miocene.
Yeah.
And could you give a short brief information about the data? How much is the oil generation in these levels? What's the oil production of the oil and gas production in these lower levels?
Okay. As you know, the South Caspian megabasin is non-compensated layer, and it's always plunging due to the turbulent flows that goes from the rivers to the South Caspian basin, and but the sedimentary rate is not as quick as the plunging rate of the South Caspian megabasin. That's why it's always plunging, and when it's plunging, these deposits, these layers that take place here, they are going down, and from 15s to 150 and to 250s. So when it past this stage, when the transformation process goes from all organic material to hydrocarbons, it starts moving into the anticlines where it all together, and from where we can explore, produce this oil deposits. When it goes to the there are some layers that are the plunging rate is, as I told before, it's high, and if the layer didn't have an opportunity to transform its organic material deposits into the hydrocarbons, it can make it in the late stage of the main zone of gas generation. In 250, there are 5 mesocatagenesis zones. MK1, MK2, MK3 refers to the main zone of oil generation, and MK4, MK5 to the main zone of gas generation. So after the the diagenes, we have the protogenes, and where the gas and the rocks are divided. When in the protogenes, the process of this is finished. After that, these rocks are turned into the fluids, and yeah, that's how it is. Okay. I hope I answered your question.
One question. Actually, as a child, I have heard every time we have very special oil. What a specialty of Azerbaijan.
It's really light.
Oil.
It's really light because it didn't have other fluids inside. So it is a clean hydrocarbonated oil. That's why it's really the quality of this oil is really good, and yeah.
What do you think? Should we use it as a and now we are using our oil, and everybody also use our oil as a energy resource. Should we pursue this process, or should we use it also? Of course, there are
different alternatives to use the electricity, because right now this sphere is really developing. There are the amount of electric cars increasing. That's how, of course, it's not. I think, in my point of view, it's not a correct using of the oil, but. Right now we are in the stage of technology increase, technology development. So maybe in future we will use the oil not as the resource for the autos, maybe in other ways. But yeah, I think it should be less used for the for this sphere.
For chemistry, it's also usable.
Yeah,
our oil is also one of the best oil in the world for chemistry industry.
Yes.
Okay, is good. You talk about this generation oil and gas. I have questions about total organic matter in practice.
Can you speak louder?
I have questions about total organic matter in upper and lower productive series in Central Zafer and Alosar.
Actually, I don't have enough information about these oil fields.
Do you have any questions?
Yeah.
Don't be shy.
Other questions, please?
Okay.
Okay. It was very nice also presentation from Javad Rustamov. Thank you very much. And it was also very interesting because the oil and gas generation in Azerbaijan is the main topic nowadays, and this topic always in the point of the view. So I would like to okay. I would like to introduce the third presenter, Umur Muradova. She is a bachelor student at the Pakistan State University. She has a lot of very professional associate activities, such as she is a student chapter president of Azerbaijan Society of Petroleum Geologists, as well as she is a member in a lot of scientific communities, such as member of Azerbaijan Society of Petroleum Geologists, member of Society of Petroleum Engineers, as well as Caspian Engineering Society. So she will be presenting alteration of cement substance or productive series from Archipelago, the western flank of South Caspian Basin. So if she is ready, you can start with your presentation.
Hello ladies and gentlemen, it's the last section, and how's everybody? How are you feeling? Are you sleepy or not? Okay, I am Gumru Muradova. I study at Baku State University, and I am going to talk about alteration of cement material in productive series from Baku Archipelago and the western flank of South Caspian Basin. And the topic outline: introduction, discussion, conclusion, and references. And I'd like to give a little bit information about geology of South Caspian Basin. The first location of South Caspian Basin. South Caspian Basin in general divided into three parts: North South Caspian, Central Caspian, and South Caspian. Here, and South Caspian Basin is located between Greater Caucasus and Köpekdağ. It is bounded by Talış, Alboruz, and Abşeron still in the north. And the second one is sediments of the South Caspian Basin. There is more than 20 kilometers of sediments, and all sediments carried by the rivers, such as Paleo-Volga in the north, Paleo-Kura, and Paleo-Amudarya. But the main prone sediments reservoir was the Paleo-Volga. It played the main role in the accumulation of sediments, and about 10 kilometers of sediments deposited by the rivers. And it's the stratigraphic column of the South Caspian Basin. If we talk about the productive series, we need to know the stratigraphic column of the productive series. It's the productive series in general divided into two parts: upper productive series and lower productive series. And productive series sediments formed during the late Miocene and early Pliocene. And you see, and my research area was the Balakhane Suite, which is divided in horizons, and 5, 6, and 7, and Pereva Suite was the productive for the Duvanla and Sangachal Deniz, which was my research area. Okay, this is the location map of oil gas fields of South Caspian Sea. And my research area was the Sangachal Deniz and Duvanla Deniz. Here is the Sangachal. This is little one is the Duvanla Deniz. These highlighted places. And okay, if we talk about the cement material in productive series, we need to know what kind of cement is distributed in the productive series. It's the calcium carbonate. And okay, the alteration rhythm of calcium carbonate in productive series. In general, calcium carbonate in widely spread in the productive series layers. There is the and this area is located in the arid climate zone, and it helped to forming of the calcium carbonate. And the second one is the chemical and physical process which has helped to forming of the calcium carbonate. A main thing, why do we need to know the amount of the calcium carbonate in the rocks? So first of all, we can determine the paleogeography of this zone, and the second one is to determine the quality of rocks. How many geologists are here? Okay, geologists know that the first one, this is sand grain, which is fragmental rocks, and this is the pores. But the second one, all pores occupied by the cement. If there are, for example, rocks occupied by the cement, it is not good for oil and gas existence in the petroleum system, because it is the reduced porosity. It's directly influence the porosity of rocks. that's why we need to know the amount of the calcium carbonate to determine two things, like paleogeography and the quality of rocks. Okay, here is the graph and the table. You see, the first research area was the Sangachal Deniz. There's the well numbers, which is core sample took from, and the depth interval, and it's the calcium carbonate with percent amount of the calcium carbonate and effective porosity. And if you look at the diagram, we can see calcium carbonate, calcium carbonate and effective porosity are opposite to each other. Like if the calcium carbonate increase, then effective porosity decrease, because all like pores occupied by cement. And I took the graph, the average number for depth, and the depth and the rate. There's the two lines. Blue is the shows the amount of the effective porosity, and the red one is the rate of the calcium carbonate. And if you look at the graph, you can see it's like calcium carbonate observed like contrasty. In some layers increase, but in some layers is not. And we will talk about that later. Okay, the second research area was the Duvanuk Deniz. It's the same well numbers, which is core sample took depth interval, calcium carbonate with percent, effective porosity with percent, and again two lines. Okay. The main thing. After I decided to make a decision, I decided to combine two structures, and I made the one graph. You see here, and the same effective porosity and calcium carbonate. Okay, in some layers you see calcium carbonate increased, but on the other hand, our effective porosity decreased. And if we look at this graph, we can see it is like distributed like contrasty. And to make a decision, I said if we combine the high amount of the percent calcium carbonate and the low amount of, we get the curve. Blue one is show the rate of the calcium carbonate, and the red one show the rate of the calcium carbonate, and blue one the effective porosity. And okay, if we do the same thing for effective porosity, we get the green one, which shows the effective porosity. You have a green line, which shows the effective porosity. It's the depth again. Okay, and like to make a decision, I decided to put the average number because it needs to be clear for everybody. It started from 2,000 meter until 5,000, and over the 5,000. After 5,000, 5,500 meters, we don't have any core sample because it is so difficult to get the core sample from there. Well, and okay, here are the two lines: calcium carbonate curve and effective porosity curve. And to take into account the consideration of the characterization of like decreasing, increasing calcium carbonate and effective porosity, we divided three zones, like first zone, second, and third zone. Okay, and the amount of the calcium carbonate in layers is related to some physical chemical process, which is the first zone. Okay, first of all, we know the carbon dioxide. Amount of the carbon dioxide is higher in the seawater than the atmosphere, because it is a soluble, can easily react with water and form hydrocarbonic acid. And hydrocarbonic acid is not so unstable, and divided hydrogen and bicarbonate. And in the seawater we have a lot of calcium, and it can easily react with hydrocarbonic acid and form calcium bicarbonate, which is soluble. It's not cement yet. And during the sedimentation, the temperature was higher, and calcium bicarbonate divided into calcium carbonate, water, and carbon dioxide. And this reaction is the turn. Like if you look the first zone, you see calcium carbonate decreasing, but effective porosity increasing. It's related with okay. And temperature was higher, and this zone we have a lot of organic material, carbon organic material, and carbon organic material, and in here have a lot of underground water which has enriched with oxygen, and oxygen can easily react with carbon organic and form and there happen reaction of oxidation, and it helped to increase the carbon partial pressure of carbon gas. You know, the forming for the forming of the cement, the first of all it helped the pH, which is hydrogen ion concentration. The second one, partial pressure of carbon gas. For this zone, for the forming of the cement, partial pressure of the carbon gas helped play the main role of this process, and that's why we have high amount of the partial pressure of carbon gas, and it can the reaction going the turn it can either okay, we have high amount of partial pressure. We have the high amount of the partial pressure of carbon gas, and carbon this partial pressure solve the calcium carbonate again from the calcium bicarbonate. That's why we say here effective porosity, that's why increased, because reaction going turn, like again the calcium bicarbonate formed again. For the second zone, we see the opposite process, which is calcium carbonate increased, but effective porosity decreasing. And we assume that this zone, this reaction not turns, like calcium bicarbonate divided calcium carbonate cement. But here we don't have any organic material, and we don't have any underground waters which has oxygen, and oxygen can't oxidize organic carbon. That's why partial pressure of carbon gas is not higher and is not solve the calcium carbonate, and the calcium carbonate deposit all the pores as a cement and occupied all pores of the rocks, and that's why we see here the second zone our calcium carbonate approximately 40%. If we look at the third zone, they are going the same process like the first zone, because effective porosity increased till 42, 43, and calcium carbonate decreased until 5%. And I show you for the third zone this reaction. You know, if we get the if our depth increase, then pressure increase too, and this pressure directly helps to increasing of the partial pressure of carbon gas, and again partial pressure of carbon gas help to solving calcium carbonate, and again calcium carbonate like this reaction going the turns and form calcium bicarbonate again, which is soluble, is not cement. That's why we see this zone, you see effective porosity, that's why effective porosity increased. And the conclusion, we determined 3 zones for alteration cement material on the basis of the post-sedimentation model. The first zone, initial zone of carbonate cement. The second zone, we call the recarbonization zone, which is we see a high amount of the calcium carbonate. And the third zone, decarbonization zone. D means like without calcium carbonate. Okay, and the first zone and the third zone is the more prospective zone for oil and gas existence, but the second zone is the minimum prospective zone for oil and gas existence. These are the references which I used, and thanks for your attention.
for your nice presentation, and it was very interesting to hear you. And so the topic was very sophisticated, and I don't know a lot of information from the geology, so the zones and carbonate, and there was also information about some kind of oxidation process. So if there is any other questions, if there is questions, please ask now. So from geologists, I would hear.
You have to excuse us. I think the scientific
it was so much
like it's you, and we are mostly like politicians. But it was very interesting. I studied also geography, and I could understand some, and it was very interesting. But I think for most of it, it's very difficult to follow geology. But it's very interesting.
It's even difficult for me also. I'm an engineer, and I'm also not a geologist, but it's also I understand that there's a lot of economists and the study is politics or something, and we are also in the place where for example the time is past and some of you can feel tired, but I would like to take attention to this panel since it's very important, and science and technology, they are very connected with each other, and it's the main goal also of this conference to give an introduction of the technological and science that's from the new scientists. For example, she studies bachelor, and she did such kind of work. It's very good, and it's very how to say perfect. Investigation.
For sure, you have to present us. So you also have to know about your topics. So you listen to us.
As a marketer, I want to ask you one question. What is our cement potential in Azerbaijan?
It is a different thing. Cement material in geology is different than cement. There's not same.
This porosity
process cement is the most famous in Azerbaijan.
You have talked about this porosity process, yeah? For example, if we are using in this process sand, it's aggregates or it's sand and water, or
no, sand is the porous, which is water can through the sands, and sand is the reservoir rocks for the South Caspian Basin.
Okay.
Sand and cement materials are different.
Okay, I have a question. You made an investigation on the porosity of the cement, and you divided rocks, and you divided it to 3 zones. And can you give us a short information based on which tools or which applications, or what was your focus when you were dividing into 3 parts, and which tools you used in order to make such kind of simulation, and how did you get these data in order to build these diagrams or something like that?
Okay, I took all data from the lithology and petrography department from the State Oil Academy, fund of the State Oil Academy, and I put the graph and analyzed all the process. Because it's still some chemical and physical process, but divided into 3 parts, I take into consideration like where the calcium carbonate increase and where the effective porosity decrease. And that's why I divide into 3 parts.
Okay, and there is one diagram. Can you go back?
This one?
So this one, and you made an approximation and based on effective porosity and calcium carbonate. In the case of as I see to this diagram, I see very complex distribution of both effective porosity and calcium carbonate. How did you use, based on which approach did you use this approximation, and how did you get these diagrams?
Here the high amount of the calcium carbonate and low, and here like to make a decision, that's why I combined all the high and lower.
You just took the average.
Took the average.
Okay.
You see here, this plus shows with this one. For example, this one, for the effective porosity.
Okay.
The green plus.
And what's the
higher. And the bottoms bubbles for the green or red. This for the calcium carbonate here.
And in this second, can you go back? In second zone, what does this red lines mean?
Red lines means calcium carbonate curve. It increased till 35%.
Okay.
Here the decarbonization zone. Ray means high amount of the calcium carbonate. Here the D. Decreasing to 5 or 4%.
Thank you very much.
Okay, if there is any questions. Thank you very much for your information and for your research presentation. So I think it's more focused on the geology part, and you can have a seat. It's mostly focused on geology part, and we have 3 geologists and 1 renewable energy scientist. And so I would like to introduce the last presenter. His name is Zohrab Javadzadeh, and he did his master degree in geology of oil and gas basin in Azerbaijan State Academy, and he's now employed in SOCA Azneft Petroleum Union Oil and Gas Production Office at the Geological Department. He has got the first scholarship in BP. First time he was awarded a BP scholarship, and he was also a stipendiate of SOCA. He has a publication and he has a good professional side society activities, like he was a president of chapter president of Armenian American Association of Petroleum Geologists.
Yes.
It was a big mistake. Okay, you can start with your presentation.
Okay.
You will be presenting us the future of the development of the local structures of global fluid, depression, and Baku archipelago.
Good morning. My name is Zohrab Javadzadeh, and my topic is about the features of the development of the local structures of Lower Kura Depression and Baku archipelago. Before me, Mr. Javad Rustamov gave us a lot of interesting information about geodynamic and evolution history of Southern Caspian Basin. And as we already know, I say just a moment. Yes. And as we already know, as a geodynamic regime by the end of Eocene, the region led to the disconnection between South Caspian. I'm sorry. Between South Caspian and Black Sea, and Lower Kura. And so this geodynamic process contributed to the unwatering of the Lower Kura part of South Caspian, forming its western side, and the established of compressive stress regime north-east orientation in the Lower Kura Depression and the Baku archipelago. The band as a positive form of production strata, it's lower Pleistocene, and the increase of thickness of the Paleogene Miocene Azerbaijan deposits on the west side of the South Caspian confirm the formation of bending deformation in the western in the western side of the South Caspian. So by forming the western side of South Caspian Basin, in paleogeographic view, the Lower Kura depression become isolated sub-basin with 20 kilometers thickness of sedimentary cover. But in the stratiotectonic view, the Lower Kura depression has remained as overland continuation of South Caspian Basin. This is also evidenced by the features of the developments. The features of the development, the spatial orientation of the local structures and of the anticline zones which they form. This genetic link between the local uplifts of Lower Kura depression and of the Baku archipelagos is also connected with the regime of compressive stress formed here by the above noted reasons. In order to research in the characteristic of developments of local uplifts of Lower Kura depression and Baku archipelago and relationship of the development, we constructed graphs of the intensity of growth of the structures of Lower Kura depression and Baku archipelago on the basis of paleoprofiles and by analytical method and then correlated them. We done it in order to identify the beginning of birth and the features of the developments of the structures in connection with the false forming process in the Lower Kura depression and Baku archipelago. And maybe I forgot to explain you. It is Lower Kura depression and it is the western or overland continuation of South Caspian Basin. Or Baku archipelago is about this region. Yes. And okay, Lower Kura Basin, Lower Kura depression and Baku archipelago are relatively deep depressions of South Caspian basins. As a result, in favorable paleogeographic conditions, there is formed a sedimentary cover with a large thickness, it's 20 kilometers. There are also independent oil gas generation depressions in South Caspian Basin. This is evidenced by the development in the South Caspian Depression and in Baku archipelago. Many mud volcanoes complicates a lot of local uplifts. And it's known that the mud volcanism has direct genetic relation with oil and gas formation process. Because of this, usually all the structures that are complicated with the mud volcanism are usually the oil gas bearing. Anticline zones of Lower Kura depression, as a rule, have continued in the offshore of Baku archipelago. So we will consider the correlation between the structures of the anticline zones that begin in the Lower Kura depressions and continue to Baku archipelago. Compressive stress regime established here since the end of the late Miocene directly influenced the development of local structures in the Lower Kura depression and the Baku archipelago of the South Caspian. Now we can see the gross diagrams of Garabarlı, Nefçala and Şirvan structures. They are located in this Garabarlı structure, Nefçala, and there is about there is Şirvan structure. How we can see Garabarlı and Nefçala is located in the Lower Kura depression and Şirvan located in Baku archipelago. Then we can see that Garabarlı structure was inception not later than Microbe time, and in late I'm sorry. And in late Miocene, the growth of the structure continues, and in the questionary time and Pleistocene questionary time is the most intensive of growth of this structure. Nechala and Shirvan structures also was not. There was inceptions not later than the time of the lower productive series, and the Nechala structure in the time of the upper production series and late Pleistocene, we can see some decrease in this in its growth, and questionary time also characterized with increase of this evolution. But structure Shirvan characterized with some stable growth with stable rate. Then we can we will research the structures. Just a moment. Kalamadin, Chiharami, Bandovan, Atashka, Yanantava, and Muramdanis. There we can see that Kalamadin and Chiharami structures was inceptions not later than Pont time, and structure Kalamadin has intensive growth history, and the most growth history characterized in the time of Pleistocene and Quaternary. But structure Chiharami has three stages in the developments, and the first stage is Pont time, and after it's Pleistocene time. Pleistocene time characterized in some increase in evolution, and Quaternary time is the most intensive of growth of the structure. Then structure Galmas and Khadırlı, these diagrams. Structure Galmas and Khadırlı was inceptions not later than the time of the lower production series, and this and structure Galmas and Khadırlı also have three stages in developments, and the first stage is characterized the early Pleistocene, it's lower Pleistocene, and then we can see there some increasing of the rate of development. It's characterized the late Pleistocene, and Quaternary time also characterized with the most intensive of the growth of the structures. Then structure Bandovan was inception not later than Mycop time, and it characterized with the three stages also, with the three stages, and the first stage is continued to the time of till late Pleistocene, and Pleistocene, but Pleistocene time characterized with the increase of the development, but the difference between this Bandovan structure between the other structure of this anticlinal zone, that Quaternary time we can see the degrees of growth of structures, and then we will research these three structures. They are Yanantava, Atashkan, and Muramdanis. Structure these all structures also was inception not later than the time of the lower production series, and have also three stages, and it's this development is standard, so it means that between the upper production series and late Pliocene, we can see some degrees of rate of growth, and questionary time characterized with the increase of rates. Then I will tell about structures Garasu, Arandanis, Dashlu, and Sabayil. They all located in Baku archipelago. These structures was inception not later than the time of the low production series. And Garasu's structure have two stages of development, and second stage is questionary time, and the second stage characterized with a more intensive of growth than the first stage. And then Arandanis and Dashlu, these structures are characterized by three stages of development. The first stage is the lower production, the time of lower production series, and then two stages characterized with some degrees of rate of growth, and the questionary time we can see the intensive growth of these structures. And then Sabayil structure, it's a yellow diagram, this structure has three stages of development. The first stage characterized by lower Pliocene, and then began a second stage is late Pliocene. In the late Pliocene we can see some the degrees of rate, and then we can see the most intensive stage characterized by questionary time. And in conclusion, we can say that due to the fact that all the considered local uplifts are the injections structures or the manifestations of mud volcanism with its root from Oligocene Meissen, and by according to a paleoanalysis shows that the structures were not later than the Pliocene. All the structures are constitutional type, which indicates the high prospect for oil and gas. In the history of the majority of structures is allocated mainly three stages according to the intensity of their growth, that associated with period of active tectonics and geodynamic processes. For example, the disclosure of Red Sea Rift since the late Meissen results in a compressive stress in the region. About this process told before me Javad Ustamov. And this is evidenced by the development of mud volcanoes in the region and the increased activity in the questionary time. The general rule of all local structures is that a three-stage growth rate suggests that Kura Basin and Baku archipelagos represent a single structural tectonic element of South Caspian Basin. Some differences in the phasing of the development of local structures associated with the ARiG mechanism of the formation and the particular situation within the faults in consideration geostructural element. The overall orientation of local uplifts and anticline zones of Lower Kura Depression and Baku Archipelago, mainly in the northwest southeast direction, reflects not only on the structural tectonic unity, it is also about development their compressive stresses in the northeastern orientation. It's known that the complication of fault dislocations of local uplifts and rejuvenation of the previously laid is usually the most intense periods of growth faults. From the analysis of the developments shows that the majority of them had the most intensive development in the quaternary time. From this it follows that a lot of faults, complicated considered structures was formed or rejuvenated in the quaternary. This is also evidenced by the numerous outlets of oil and natural gas in the Lower Kura Depression and Baku Archipelago. It's at the same time it is at the same time suggests that a lot of faults in the structures formed after filling of their traps with hydrocarbons. As a result, they contributed to the destruction and reorganization of previously formed clusters. So thank you for your attention. If you have any questions, I can to answer.
Yeah, I have one.
Yes.
Can you show the charts of the structures? Yeah. Yes. Next. One forward. Yeah. Forward. I will show you. Go next.
This?
Next. Next. Pause. Stop.
Yeah.
Can you explain me all these charts? The capacity thickness was approximately developed for 6 million, sometimes 7 million. Why the Bandovan structure was developed so long? What was the impact? Influence on that?
It's okay. It's because the structures Kalamatin and Kchiharami was inceptions not later than Pont time. Why? Because we have material for Kalamatin and Kchiharami, for example, Kalamatin and Kchiharami, till Pont time. And for Bandovan structure, we had materials for time of Maikop. So there can be difference with the times, because these diagrams including pond, Pleisen and quaternary, but there is it's Maikop, Maison, then Pleisen and Petersen and quaternary.
Yes, but during 7 million years in Kalamatin, Küçük Harame and the others was accumulated approximately 3,000 meters. And here in 30 million was only 1,500. Why it's so slow?
Why Kalamatin and Küçük Harame has more intensive than Bandovan?
Yes.
But now it's physiological. Just a moment. We can look to the map.
And the one is there.
Yes. Just a moment. Yeah. This I think it can depend on the locating concrete locating in the geostructural element, and and also you can see that band 1 structure also different with the other these structures. Then the questionnaire period, we can see degrees of the rate of growth. But the others, all the other structures then we now researched. The questionnaire period characterized with the most intensive of the growth. But band 1 questionnaire time characterized with the degrees of the rate. Thank you.
Can I ask one question? Actually, most of us, we are not geologists, and this sophisticated, it's very, it was very interesting, but was so much sophisticated for us. But all of you have mentioned one thing: we have mud volcanoes, and we are in the first place. Yes, about it. How we, what is it? How we can use them? Can we use them as a touristic places? Which future will bring us to this mud volcanoes?
Yeah, mud volcanoes, Azerbaijan. The most quality of mud volcanoes located in Azerbaijan. It's about 300 of mud volcanoes located in Azerbaijan. Some of these active, some of these are not active, some of these buried under the sediments. And the mud volcanoes sometimes this is called then natural wells, and it is the fire of mud volcanoes. Fire. It's not fire. It is. It is in the deep in the micro series, and micro series is it's known that micro series it is the south rocks in Caspian region. Not only in Caspian region. It's also Caspian region have some connection with Black Sea region, and how we there we can see.
In which field we can use this volcanoes? I mean,
which
is mud? Yeah.
How we can use it?
What advantage will bring us this kind of good volcanoes? I don't also get this.
What's connection between volcanoes and?
For example, and you have said the best mud volcanoes in Azerbaijan. Yes. Yeah. It's a mud. Why you have said it's the best?
Like for tourism, you can use them. It's
for medicine, for wellness,
also for medicine. It's also for medicine. Also, we can research on mud volcanoes for research the deepest part of the earth.
Are we using it at the moment?
Yes. Now in Azerbaijan. There is not Naftalan. It's other area. It's other area, and Naftalan is there. Naftalan is here. Naftalan characterized not by volcanoes. Naftalan characterized with the unical medicine oil. Yes. But not volcanoes characterized with the medicine mud. And also we can research volcanoes because we can get a lot of information about the deep part of the earth, about for example about south rocks.
Can we produce energy from mud volcanoes? Is it possible?
Maybe in future, because now it's possible, of course.
Give us information about it.
I say German.
Ah, okay.
Wir können Geothermal Pump in Mundvulkansbereich installieren und gibt es schon in Praxis, zum Beispiel in München, gibt es eine Installation in tief 2000 Meter und sie kriegen da Strom. Das gibt es in Praxis weltweit.
Ja?
Ja, bitte.
Ja, ich weiß nicht, wer von Ihnen war schon an den Schlammvulkan? Wer von Ihnen war schon bei dem Schlammvulkan?
Ich war nur in Aserbaidschan. Im Schicki-Bereich, nicht Schicki, Schamachel. Das ist noch. Also,
die sind erstmal kalt.
Das ist kalt, ja.
Keine Vulkane, sind
aber
kalt.
in Tiefe 2000 Meter,
ja,
das ist nicht kalt.
Das ist ein einzigartiges Phänomen. Wir haben nur an 2 Stellen in der Welt Schlammvulkane. Das sind einzigartige Phänomene. Deswegen möchte ich das nochmal so auch ins Publikum sagen, weil sie bis jetzt nur so unter sich diskutiert. Wir haben die in Südamerika und in Aserbaidschan. Und diese wenigen schönen Schlammvulkane jetzt anzubohren in 2000 Meter Tiefe, ist eigentlich völlig unsinnig. Wir haben so ein Potenzial touristischer Art, natürlich auch mit Wellness. Wir sind einfach ein Naturwunder. Und wenn wir anfangen, alle Naturwunder anzubohren, dann wird es etwas, dann sind sie kalt, da können sie reinfallen und dann haben sie ein schönes Schlammbad genommen, das ist faszinierend, sie fühlen sich wie auf dem Mond. Und das ist das Hauptpotenzial eines Schlammvulkans. Sorry. In Bolivien gibt es sie, glaube ich, auch, ne?
Ja. Eigentlich, wir wollten auch diese Meinung hören, aber wir recherchieren noch. Gibt es solche Potenzial oder nicht? Ja.
Wir sprechen jetzt nur über den Potenzial. Wir sagen nicht, dass wir das gerade benutzen können oder so. Aber nicht alle Vulkane in Aserbaidschan ist kalt. Kalt ist nicht kalt.
Ich habe bisher nur kalte gesehen. Ich habe sehr viele schon gesehen. Und langsam sind sie lauwarm, aber keine Vulkane, weil bei uns die Assoziation mit einem Vulkan im Deutschen ist heiß, ist Hitze. Ja? Und das sind im Moment eben keine Vulkane, sondern kalte.
In Welt gibt es 800, aber Mundvulkane und 400 gemeinsam ist in Aserbaidschan.
Das ist doch fantastisch.
Ja, ja.
Das ist einzigartig. Wie gesagt, Naturwunder muss man als Naturwunder vermarkten.
Wir sehen das nur wie Potenzial für Zukunft.
Nehmen Sie die Sonne, aber bitte nicht die Schlammvulkane.
Entschuldigung, wird etwas sagen.
Yes, of course, they are the process of formation of the mud volcano. He said that the potential of the mud volcano it can use first in the science because the rocks that are connected, that are situated in the really ancient layer, they are took with the temperature due to the pressure, and the pressure is influenced with the temperature. That's why it is hot, but I haven't heard about that cold volcanoes actually. Yeah, maybe it's phenomenal. Also, we use it in cosmetic ways.
Yes.
Not quite.
Okay. It was very nice discussion. So you can have a seat.
Thank you very much.
So, I hope it was very interesting for you to hear these presentations about from geologists and from engineers, and I hope in the future there will be more scientific researches connected with Azerbaijan oil, gas, and other resources, as well as alternative renewable resources. So now the panel is going to be end, and there will be okay. Now I want to give the word to my colleague.
Meine Damen und Herren, Zunächst möchte ich im Namen des Azerbaijan Student Network euch allen ganz herzlich danken, den Rednern für die spannenden Vorträge, den Teilnehmern für die lebhafte Diskussion, den Zuschauern für die virtuelle Teilnahme und euch allen übrig geblieben für viel Geduld. Und ich habe auch einen ganz großen Dank zu sagen an Frau Professor Dr. Eva Maher auch, an Frau Julia Stadtfeld und an alle netten Mitarbeiter dieses Lehrstuhls für Geschichte Aserbaidschans für die tolle Zusammenarbeit. Ich habe zwei wichtige Ansagen außerdem. Ja, für alle, genau. Sorry, ich kann nicht alle namentlich jetzt erwähnen. Zuerst diejenigen für euch, die einen Kopierer brauchen, um ihre offiziellen Angelegenheiten zu erledigen, bekommen diese Möglichkeit morgen 9:45 hier. Außerdem machen wir jetzt gleich um 7:30 einen Empfang im Hilton Hotel hier um die Ecke im ersten Stock. Ihr seid alle herzlich eingeladen. Ihr könnt gerne eure Freunde und Bekannten mitnehmen. Es wird mit freundlicher Unterstützung des Direktors der Sokar-Repräsentanz in Deutschland, Herrn Elmar Mamedov, veranstaltet. Ja, und wir würden uns freuen, euch alle da begrüßen zu dürfen. For those of you who don't speak German, I will repeat the two announcements. The first one is that those of you who need the photocopy will have this opportunity tomorrow here at 9:45, and now soon at 7:30 we will have a dinner, an evening at the Hilton Hotel. Is here 300 meters from here. Thank you very much again for the great conference day. Bye.
Ich bedanke mich auch nochmal ganz herzlich für den Dank. Ich hätte noch zwei Vorschläge, und zwar haben wir vorbereitet eine stumme Karte. Wir hatten ja heute davon gesprochen, wie weit reicht Europa oder wie weit reicht Asien. Wer Lust hat, kann sich daran beteiligen. Also wir brauchen keinen Namen drauf zu schreiben oder so. Wer Lust hat, kann das natürlich. Einfach einzeichnen, wie weit reicht Europa. Wir wollten ja Identitäten mal ein bisschen testen, ob wir da wirklich zu einem gemeinsamen Ergebnis kommen oder nicht. Wir können das morgen ja einfach mal an die Wand bringen und schauen uns das an. Und ein anderer Vorschlag geht in die gleiche Richtung. Wir werden morgen ja eine Abschlussdiskussion haben, Vorschläge zur weiteren Entwicklung der Aserbaidschan-Forschung. Und man sollte heute noch vor den frischen Eindrücken vielleicht sich kurz notieren auf einen Zettel ein Stichwort, und dann hätten wir also auch so eine Art Pinnwand, die wir machen, wo man dann schon mal einzelne Gedanken vielleicht zusammenfasst. Das kann einfach morgen früh mitgebracht werden, und dann haben wir hier auch so ein bisschen ein Arbeitsergebnis, das wirklich nach Workshop dann vielleicht aussieht, aber dann haben wir eine Basis. Das ist ja meistens so, morgen gibt es noch mal eine interessante Diskussion, dann verschwindet der ein oder andere Gedanke, und so hätten wir dann also auch optisch ein Arbeitsergebnis. Also wenn Sie Lust haben, würde ich das einfach vorschlagen, auf Zetteln notieren, anpinnen. Wir werden morgen so einen Tesafilm das einfach hier anpinnen. Ich wünsche uns allen einen schönen Abend und herzlichen Dank.